going to get started and finish up 1.6 today. We're talking about the absolute value. What does it mean for something to be positive or greater than 0? Are we looking for the positive region or the negative region? Positive. Also, we're looking for any closed dots. So this tells us we're looking for the positive region, and we're also looking for any closed dots. Okay? So we're looking for two things based on how that problem looks. So right now, can the numerator equal 0? Where at?
3 negative.
At 3, it can equal 0. But, oh, don't forget we have this. Your first thought when you see the denominator, x can't equal what?
3.
Right, so x cannot equal 3 and negative 3. So I put that on my number line as instructed so I don't forget and lose valuable points coming up on Friday. So, negative 3 and 3, those are open circles because they cannot equal that. So is there anything like x squared plus 1 equals 0? I don't think so. And the x minus 3, we've already taken care of that. It can't equal 3, so we're in good shape. So there's no closed dots from the numerator. Only open. You guys all right? What's wrong? Aye, we're on a graph situation. Or else he'd be right. Oh, we have to check the regions now. If I put in 0 into this first factor, will it be positive or negative? If I put 0 into this other factor to the right of it, will it be positive or negative? And if I put 0 down in the denominator, it will also be negative, correct? So that turns out to be a positive region. Nice. If I put a number like 10, well, let's do negative 10. If I want to check the far left region, any number I put in, like negative 10, negative 100, will come out positive in the first factor, negative in the second factor, and positive in the denominator. So that's going to be an entire negative region. And finally, if I put in a positive 10, first factor will be positive, second factor will be positive, and the denominator will also be positive. So that's a positive region also. The rush to judgment is, a lot of people put negative 3 to infinity, forgetting that it can't equal 3 also. So how do you join two regions together? Union. Union by definition is joining of two elements. In this case, we were joining two intervals of solutions. So, very nicely done, very easily done. That was number 36. So if we do multiples of 6 for our check, you're in good shape. I won't do multiples of 6. Maybe I'll be even. Any questions? I think we just have a few to do. Should be very long. Oh! The first thing people do is, yes. And then they analyze it. And then they realize it doesn't equal 0. So how do you know if you're looking for the positive or the negative region? You make the call. You want to work with positive or negative numbers. What is that? Only to you. Positive, so that means everything on the left's going to the right. 0. Now I've set it up to work with positive numbers. Wait a minute. Can't you cross multiply and all that other stuff? Well, you could, except you have to account for what? Well, okay. X minus 2 over 3x plus 5. Why didn't you? Why? Nobody said anything about what it can't equal. Well, see, on this one, I'll probably just keep the denominator because it's fun. But we all know it can't equal, x can't equal negative 5/3, right? I'll probably just keep it for fun. There's nothing wrong with that. You have to keep it if you're going to graph it out anyway. We already know how to do this. Multiply it by a factor of 1. So 0 is less than or equal to 12x plus 20 minus x minus 2 all over 3x plus 5. No sense in keeping the factor till the end. It helps you graph it out anyway. Here, mind you, it's probably going to be a vertical asymptote if you were to graph it out. But anyway, I just got a common denominator. Multiplied by 3x plus 5. So I have 12x minus x is 11x. 20 plus 2 is 22. All over 3x plus 5. And, again, I'm looking for the positive region because it's bigger than 0. And I'm looking for any closed dots. That might come from the numerator. Is there anything that makes the numerator equal to 0? 11x plus 22, negative 2. So I know there's a closed dot at negative 2, and that's fine. I'm looking for closed dots. And I know there's an open dot at negative 5/3. Now, is that on the left side or the right side of negative 2? Right. Negative 5/3. Now I just have to check for the regions. Everything right, Chase? I said right. Oh. My right. There we go. Well, it depends which way I'm facing. I was turned around. I was just in a hurry. Oh, test numbers. Negative 10. Negative region, right? Or I'm sorry, negative divided by negative, so it turns out to be a positive region. What's the number between negative 2 and negative 5/3? Negative 7/4, somebody said. Okay? You don't do that? No? Well, why not? I don't know, this is the same as negative 6/3, isn't it? Negative 5.5/3. How's that? What? That's going to make that a negative number, right? And it's going to make the numerator negative. Oh, positive. Isn't it?
Make it positive.
I think it would. So that'd be a negative region. So we got a negative region between there. And if I put in 100, a positive divided by a positive, so it's a positive region. So I obviously want to join all the positive regions together because we set it up for a positive problem. So the answer would be negative infinity to negative 2 with a bracket and a parenthesis, union negative 5/3 to infinity. And we'll close it off. Okay? So those are the regions we're looking for. Sounds like a bunch of little kids here. Middle school. Must be taking a tour. All right. That was kind of easy. There's other ways of doing this. Is this our last one?
Yes, it is.
It is not, is it?
Yeah. There's one more.
There's one more. Yeah, I was going to see it anyway. I'm tired of doing the same old thing. Well, we'll keep going. All right. So what can't x equal? X can't equal what? 5. It's 46. Or x cannot equal negative 3/2. 3/2. Okay? So far, so good? Now that I've established that, I can go ahead and cross multiply. Sure. Last time I kept the denominator, which is fine. You can do that. But I think now I'm going to cross multiply. 2x minus 10, less than or equal to 4x plus 6. As long as you establish that x can't equal, I think it's fine. I think it's kept. Yep. Yeah, I said, is there anything x can't equal? Nobody said anything, so I shifted to the other side. We made it positive, kept it. There's nothing wrong with keeping it. In fact, if you're graphing something out, you have to keep the denominator. If you had to make a graph of this equation, you got to keep the denominator. But since we're solving, the denominator you really don't need except to establish some boundaries for the domain. Here we know x can't equal 5. Here we know it can also equal negative 3/2. So, with that said, I now know you have negative 2x. Let's see. And also I can subtract 6, right? So, 2x. 16. So x is less than or equal to 8? Negative 8. Greater than or equal to negative 8, right? Does that look all right? Okay. So I would go, I'm going to check this one. Yeah?
So when you cross multiply, you have multiply with 2 by the x minus 5. Would
Yeah.
it be on the right side or the left side?
Well, I think it goes means extremes. Yeah, it goes A dot B equals C dot D. So it goes AD. I think it goes on the left. I don't know. We got to find out. We got to do some test points and see. Maybe it doesn't even work that way. I don't know. But I'm going to graph it out to double check. That was the whole point of doing that. And it would go this way. So when you do that, you're going to run into some problems, it looks like, with the open circles, doesn't it? So if I go back to the original problem, it should imply, does 0 actually work for this? Is 2/3 less than or equal to negative 2/5? No, it's not. Must go the other way then. How about negative 10? 2 over negative 17. Is that less than or equal to 2 over negative 15? Yes, it is. So in that case, I think it would go the other way, and those points wouldn't even be in common. Another way, a way I would do this problem without is to graph it out. Have you ever graphed out inequalities before? Excellent.
No, I have a question.
Okay, go ahead.
So, why is the arrow going the other way around?
Well, he brought up a good point. How do you know which side to put this quantity on? So when we had the arrow going, we had to check. And the arrow said it was going this way. We already know it can't be 5 and it can't be negative 3/2. Could it be 0? So we put 0 in to find out. It didn't work. Now, this is how I would do quite a bit of these problems, actually. Let's see, view. I like the positive approach that you had. Okay? So I would take everything to the right side. And on a graph, you can see a positive approach. So if you go to y equals, you can take 2 divided by parentheses x minus 5 minus 2 divided by parentheses 2x plus 3. If I put that in, now I'm looking for anything that's positive. Where does positive show up on the graph? On the x, y graph, where does positive show up? Where? Close. That's when the x and y are both positive. Where is y positive at? Which quadrants? First and second. We're looking for everything above the x-axis, right? Everything above. So when I hit graph, view, graph. Zoom 6. Let's tell me that there's 2 regions above this. What do you think this number is right here? Do you remember that from algebra? What do you think this number is right here? Where there's a break in the graph? 0? Not a hole. It is an asymptote. Very good. Look at it in relation to the problem. Where do you think that vertical asymptote is? At x equals what value? Anything that has a vertical line has to have a value of x equals, right? -3/2. X equals -3/2. And what about this one? Where do you think that is? 5. Where do you think the positive region is? Well, I think this is a positive region, don't you? And I think this is a positive region, don't you? So it looks like everything between here is going to be negative and not going to work. So it looks like the answer should be from negative infinity to -3/2, and then from 5 to infinity, doesn't it? Oh! You know what that means? That means you always have to keep the denominators. Darn it. So many people get rid of the denominators, though. What? Let's go to the positive side. Don't erase it, just add to it. Just say never do this. There's nothing wrong with that. 0 less than or equal to 2 over x minus 5 minus 2 over 2x plus 3. The problem is now we got to get our algebra to match the graph. We know what the answer is. And if you're in a bind, graph it out and you know how to read it. So we have 0 is less than or equal to 4x plus 6 minus 2x plus 10 all over x minus 5, 2x plus 3. Now it's shaping up. Is my arithmetic all right so far? 4x plus 6 minus 2x plus 10. It looks like it. 2x plus 16 all over x minus 5, 2x plus 3. Ah, now we got the players in the game. Close dot at -8. Open dot at -3/2. And open dot at 5. Well, judging by the graph, I know this region from -8 to -3/2 is going to be what? Positive. I know from -3/2 to 5 it's going to be a negative region, right? And everything past 5 is going to be a positive region. The only thing I don't know is about -8. How can you tell if -8 is going to work? Yeah, plug in a point. Second, calculate value, -9. What do you think, positive or negative? Right above here, above trace. I think it's going to be negative. Hard to tell, isn't it? So it's going to be a negative region right here. So that's our answer. From -8 to -3/2. From -8, bracket, to -3/2, union, 5 to infinity. Using the graph helps with your algebra, and your algebra helps using the graph. Yep. It is, because it can't be. See the vertical asymptote? Nice. And I think, yeah, we're right on time. The last one, this one doesn't look very hard. Solve parts and use the answer to determine the answers of part B and C. I don't know. It says solve part A. We can do that, can't we? Because that's rule number 1. We can put -2 is less than x minus 3 is less than 2. Yeah, add 3 to everything. And you have 1 is less than x is less than 5. Well, what's x going to be in part B if it actually equals 2? X is going to be what numbers? 5 and 1. That's pretty easy to see. And what about if it's going to be bigger than 2? Yeah, it's going to be what? Greater than 5 and less than 1. Or has to be in there. Okay? So it looks like you're going about 53. Does that look about right? I don't know if we have any word problems or not. 51. All right, so go to 51 odd. And then I'll go to my question for that side of the room. Bo, hope you feel better.